All right. So we're getting to where we were on Monday night, at least where I was. Maybe you've been there the entire time, but hopefully this is helpful to you. Repetition's the mother of mastery, and practice leads to progress. So we saw this on Monday night in the previous videos, discrete probability distributions. And in addition to tables and graphs, a formula that gives the probability function fx for every value of x is often used to describe the probability distributions. And some of the discrete probability distributions specified by formulas are the binomial probability distribution, right? So we're going to do that right there. We're just going to add in binomial probability distribution. That's the one we just looked at. And I'm going to make this one just like, I guess we'll leave those all the same color, because these dark orange formula and function you could use in fx. You could use those interchangeably in my book, and then these lighter oranges are just examples of that, and we already saw this one. I wonder if I could put a check mark in there. I could do this, and I'm going to put in just a little happy face, right? We're really happy about that. And the way you do that is you press your start key in Windows. It's kind of cool. And you press your period, and then it brings up this stuff. And you can look through like all these things. And moi. And you could put stuff in there. So I don't know how I get that guy in there, but he's not going. But yeah, you could look through all the emojis, and you could search through your emojis and things like that, and find different emojis you could search there. Like if I wanted, I don't know, strong, they're strong. So that's the one we already did. And so another example of a formula in discrete uniform probability distribution. Discrete uniform probability distribution is right here. And it's a simple example of a discrete probability distribution given by a formula. The discrete uniform probability function is f of x is equal to 1 over n, where n is the number of values the random variable may assume the values of the random variable are equally likely. And uniform probability distribution, when we look back to this, it's classical, all are equal, right? And we'll also put in here, I thought I did this the other night, so it must be on our slide because that's in 2 places. Right, we'll also just call that uniform, but there it is again, statistics being unclear about their language and lack of consistency in their language. Maybe they were confused by all this too. And they did their best job, and we're doing our best job, and maybe everybody doing their best job, it'll just get better and better over time. So that's the discrete uniform probability function, and it's based upon the classical method of determining probability for stuff, and that's where everything is equal. The empirical or relative frequency, again, statistics not being consistent with their language as a field, right? But this is the one where we just get the data from, a law of large numbers. We've done a whole bunch of stuff a bunch of times and measured the outcomes and what their relatively speaking probabilities were for each outcome, each sample point out of all the sample points in the sample space. And then subjective is just like, this is what I'm telling you. This is the probability, my subjective probability of it all. So discrete probability distributions, moving forward, we were here, and now that's that one. And then the next one we're going to look at is expected value. So that's what we're going to see in this video. And it took us, if it's under 3 minutes, we'll keep going. If it's over, we're just going to call this review. We're at 3:38. We'll call this review. So in this one, what we did, we reviewed formulas, functions, and discrete probability distributions and formulas and functions, and we reviewed the discrete uniform probability distribution. So I'm going to copy this, and that'll be part of the name, and formulas, functions, and the discrete uniform probability distribution, and the different methods for determining probability. That's everything we reviewed. Here are the different methods. That's everything we reviewed in this video. And in the next video, we're going to jump into expected value, standard deviation, and variance of the variable, right? So how do we figure that out? See you in the next video.